Hello, my name is Brian, and I'm here to hack on some Tiger Beetle stuff. Tonight we're going to be working on the Tiger Beetle Rust client. Tiger Beetle being a high-performance financial database written in Zig. The Rust client being the software you use to contact that Tiger Beetle server from a Rust program. If you're expecting some Zig programming tonight, there's probably not going to be a lot of it. I mean, there's definitely not going to be any of it. There's going to be Rust programming. There might be some peeking at Zig code, but this will mostly be a Rust stream. I know that's been a something people have been dismayed about my streams lately, and right now we're doing Rust, but I promise we will get some Zig on my stream eventually. If you like Zig, MattClad does a Tiger Beetle stream on this same channel on Twitch every Thursday. So this project is to create a Rust client for Tiger Beetle, and we've been working on it for weeks now. I do all the work on this stream. Tonight's going to be pretty short. I have some limited goals, but some specific goals that should be pretty straightforward. So this should go, fast and easy. Will be nice compared to the last few streams, actually. So recently we've been implementing, still working on implementing the requests for Tiger Beetle in a way that kind of provides all the features expected by the underlying client. The Rust client is a Rust library, but it binds a Zig library that provides the actual fundamental client functionality. So far, all of the language bindings for Tiger Beetle client are bindings to a single library written in Zig that exposes a C API. In the future, that will probably change, but for now, all that logic is centralized in one place, written in Zig. And we've been writing the request methods for an async Rust API that binds to the TB client library. And we've gotten to the point where we've implemented 2 of them, and the pattern we've used to implement those 2 requests look pretty good. In particular, the last episode, we worked on making those requests support multiple events or operations for a single request, which is crucial for performance. And at the end of the last episode, we were kind of at a place where we were happy with the basic pattern we had there for implementing these Tiger Beetle requests. But the API was still a bit of a mess. We're exposing, in particular, some of the underlying C data types to the Rust API, and that's no good. We got to have Rust types in the Rust API. So tonight I'm just going to try to do some cleanup, basically, and I'll talk through it, but it's going to be kind of basic Rust refactoring, no hard problems solved tonight, probably. Should be just pleasant and chill. So let's go over to the code, and remember that I frequently forget to switch to the code on here, so remind me if I'm talking and not showing you the thing that I'm talking about. In fact, let me adjust my windows a bit so I can see a little better what I'm doing on OBS. All right, so I think I've got you seeing my code. I'll zoom in a bit so you can see better. Right now I'm on the wrong branch, so I'm going to go. It's been about a week since we worked on this project. So usually the first thing I do is just kind of get back up to speed with where we left off. Rust client is our branch, and I'm going to fetch upstream and rebase. And I'm going to rebase on main. And really there shouldn't be any problems with this rebase because most of our code is all in its own Rust project. We're not really touching much of the Tiger Beetle code. And let's go ahead and rebuild our TB client C library, which is a Zig library that exposes a C API. And we need to build that every time we kind of switch branches or start work on this project again. And this is using a Tiger Beetle specific build command, clients C, building the C client. It's a static library. And now we can go back to our Rust directory within Tiger Beetle and go source clients Rust and go type that again and build it again. Just get it all primed for development. Like every time I start reworking on a particular branch, I do a type check and a build so all the dependencies are ready to go. All right, and apparently we left this in a broken state last time, or, oh no, has the API changed? This could be a big thorn in our side. I was not expecting any API changes. You can see this TB client is the underlying C library, and we're automatically generating Rust bindings to that library. And it looks like the API has changed. So we need to kind of decide right now whether we're going to continue down this rebase route and figure out what this change is, or maybe back up and keep working on our API. The route we were going to go, working on the API cleanup without dealing with this yak shave. But really quick, let's go and look at what our code is doing here in lib line 47. And then we'll go look at the C API and see what changed. Source clients Rust, source lib, line 47. All right, so this client init call has changed. And most of the documentation and the code for the client API is in this client C directory. So let's look at tbclient.h and go check out tbclient.init. So this cluster ID, okay, well, this is very interesting. This cluster ID used to be a 128-bit integer, and now it's 16 bytes, which is, I assume, also 128 bits. And this is very interesting because, for this entire project, we've been dealing with a little issue, and I'll show you on the Rust code here. This improper C types warning that we are just allowing in this project is because the Rust FFI does not have a stable ABI for 128-bit integers. So what this looks like to me is that the ABI of the C headers has changed to address this very problem, which I was not aware of. I'd be very curious to see that PR, though I don't think we're going to go look at it now on stream. But seemingly this change to the API that I'm got a build error is just because of the 120-bit integer ABI. So that's actually a great thing for us and not too hard for us to fix. So let's go find where we're calling tbclient.init. This cluster ID, we just now have to convert to bytes. And the way I want to do that, I think, is to say, I want to say into, or try into, maybe into, just to see if Rust has a conversion just defined to create a cluster ID, create a 16-element slice or a 16-element array. And in fact, we're looking at the C code, so I'm kind of curious to see what the underlying Rust definition of this is. It's probably a by-value array, but let's go look at it. And that's in our generated code for the Rust client. Clients Rust source tbclient.rs. This is generated by bindgen from that header we were just looking at. And if you go see tbclient.init, so this is a pointer to U8s. So that's interesting. And C, this is a 16-element array. But the ABI here is clearly a pointer to something. So in the C ABI, presumably this is not a by-value pass of an array. It's a by-reference pass. And in the Rust API, they don't bother to give it a dimension. It's just a pointer to U8. But it's our responsibility over here when we call it to make this a, this is a 16-element array of bytes. So calling into here can't work because this type in the Rust definition is actually inaccurate, and it's not going to provide enough type information for the Rust type checker to infer the correct type for cluster ID to be coerced to. But we can possibly try saying like here, put a type argument to tell it what into implementation to call. This could work. I don't know if it will or not. I don't even know if this implementation for U8 of 16. Trying to remember the Rust array syntax right now. So this is we want a 16-element array from a 128-bit integer. That seems like something there could be an into conversion from, but there also might not be because it's not obvious how you want to do that conversion. There could be Indianness issues, perhaps. Let's just see if Rust defines that. And this will still need to be, if this works, it'll still need to be probably dereferenced and then also cast to the underlying raw pointer type perhaps, but I just want to see if Rust will do this into conversion. Otherwise, we're going to probably have to go look in the docs and find a specific conversion function for it. And we're just going to run cargo check now. And it's definitely not super happy about that. Expected 0 generic. Okay, this is kind of ugly. So we can say the arguments to this into trait. So this is this into method in Rust is a implementation of a trait. It's a method on a trait. And I am attempting to explicitly specify type arguments, but these type arguments are not to the into method, they're to the trait itself. So to specify these type arguments, here it even says right here in the error message, it knew what I was trying to do. You can see the compiler is telling me that like, okay, this is actually what you're trying to do because those type arguments are not on the into method, they're on the into trait itself. So I'll go try to do what it's saying. What is the syntax here? Yeah. Lots of colons. That looks right. This array syntax in Rust is kind of ugly, and I forgot one of the braces. There we go. Let's see if that exists. Expected a type, found a trait. Okay, this looks like we're really going off the rails here. Expected a type, found a trait. I actually am not sure why it's saying that. This looks like a red herring to me, this add a dying keyword if you want a trait object, because I definitely don't want a trait object. Yeah, Future Highway is suggesting that I use the explicit methods to LEBENE bytes. And that is, you're probably right about that. I kind of just guessed whether there might be an into implementation here, but maybe not. To LE bytes is probably what we want here, little Indian bytes. And thank you for pointing that out in chat because I was going to have to go look that up. Let's just go ahead and forget about this, whatever we've been doing here. And it's called to LE bytes. And this will give us an array. And probably this won't type check because that array needs to be further dereferenced and coerced. And what it says we have, so we do have now an array of 16 U8s. Thank you, Future Highway in chat. That's very helpful. And now we can say, take a reference to that. So this is an array, right? This is not a slice. This is an array, which is a by value thing. So we're going to have to convert this to a pointer to constant U8. So to do that, we're probably going to have to create a reference to this. And then we'll try, I'm not exactly sure. We create a reference to it, then we might need to call like a slice method to get the pointer, or we might be able to cast it directly because a slice in Rust is a fat pointer type. And I'm not sure if direct coercions, we can get a thin pointer out of it. You know, if we turn this into a slice, it's going to have both a pointer and a length attached to it. And ultimately, we just want a pointer to U8 to fulfill this FFI here. But I'm going to do what I think might work. I'm going to say, get a reference to this and say as star const U8. And this is probably not going to work. So one thing you could do here, there's so many ways to cast things in Rust. You could say, give me the 0th element here, because we know there's going to be 16 elements. And we could take a pointer to that. But I'm going to just see what the compiler says if we do this. And then we also need to cast this to, oh, nothing else. That's as far as we need to cast it. Let's see what happens here. Maybe the compiler, oh, hey, worked. I just kind of guessed what I thought might work. So the thing that I thought might not work here is that, again, this is there's so many coercions going on here. So when we say 2 LE bytes, this is giving us an array. An array is not a fat pointer. An array has a defined, like a compile time defined length. So that's not a fat pointer. This is what is this? Array of 16 U8s, like that. But then we take a reference we're taking a reference to, you know, an array again. And in my mind, I was wondering whether this was going to further coerce this reference to an array into a reference to a slice like that. And a reference to a slice is a fat pointer. And then converting a slice to what we need, this thin raw pointer to a constant of U8, would involve throwing away the length. But of course, there's several coercions involved here. And actually, we just took a reference directly to an array, which is a thin pointer, which we directly cast to a constant U8, and it all worked. So cool. Thanks again, Future Highway. So again, right now we've just been kind of fixing this rebase problem, and now this should work. I should probably go and test this and make sure it still works, so I'm going to go do that. We've already built the C client. We can run the server. So I'm going to say server start and just refresh myself. So we're just making sure this rebase worked because we did have to make a change to how we are calling the bindings. And I think we can just call cargo run here. We have a little test program that'll link to our library. And this should output some stuff that looks reasonable. This looks reasonable. So our code's still working. Now let's go look at the API we've got going on here. So the goal today is to just kind of like go over this and clean up some of the junk here. And we already did succeed a little bit by getting rid of our annotation here that allowed the use of 128-bit ints in the FFI. And I think the first things to do are get rid of these C types within these structs or enums. So these two are both kind of query result types. Every single query in this API has a corresponding method, like this one right here, submit create account. And every one of these methods has its own result type, or at least an OK variant. So if we get an OK, if we succeed in submitting the request and get some kind of response back, we get a create account OK result. And so there's one of those for every possible type of request. And right now, there are some cases here where we just embed the underlying C types. And in an eventual Rust API, I don't want to do that. So the thing to do right now is basically redefine these two types, TB create accounts result T and TB account T, as Rust structs. And this will be mostly copy and paste. Not copy paste, but we'll just be kind of like mirroring the C definitions as Rust types. Let's go ahead and just see what it looks like. If we go to the source, we're going to look at the generated Rust bindings, tbclient.rs in our source. Again, this file is generated by bindgen from the C header. And we'll go find, I'm going to do TB create accounts result T first, just because it's a smaller type. So I'm going to look for struct TB create account result T. And so this is how it looks in the C ABI. This is a direct ABI compatible mirror of the C API. And in our Rust code, it's going to be almost the same thing. So let's just get to it. And I'm going to make room for these definitions up here, but offhand, I don't know really where I want them to live. I could even like put them in their own module to kind of like segregate them because they're this own type of thing. These are just redefinitions of the underlying C structures. But for now, I'm just going to make some space up here and create definitions. This is going to be pub struct tb create accounts result. And for now, I'm going to give it essentially the same name as the underlying struct because I want like a reader who sees this to kind of be able to like look at this and look at the C bindings and the C API and be like, okay, these things are probably the same because they have almost the same name. There's always this tension in these bindings to like try to name them in a way that makes sense from a Rust consumer perspective, or name them in a way that makes sense from the, Tiger Beetle perspective. And for now, I'm just going to copy this struct name exactly. And one thing to know about this result type is that if you see there's an index here, and we're doing some post-processing of our request that means this index is not needed anymore. I don't know if I want to explain it all in detail again here, but basically every single request may have multiple events involved. And this index exists in the response to kind of like figure out, to correlate the input request to the output responses. And that's a pretty ugly thing to have to do. So the Rust bindings have done this work already. Like we've used index for the purpose that it's for. And so I'm thinking I'm not going to expose that in the Rust API anymore. So now we just have a result, which is right now a U32. And I'm going to put a to-do directly on that because this has got to be an enum or something. And it's probably these, no, it's not this one directly above it because these are create transfer results. But this is almost certainly a C enum that gives like error codes related to what happened with the create accounts request. So I'm going to put a to-do here because we're going to have to create an enum for that looks like a nice, sensible Rust enum. And I'm going to derive some things on here because now we're thinking in terms of like the actual API we want to present to Rust consumers. So we're really thinking about stuff an API should have. So I'm going to put all the stuff. We're going to put all the stuff on the struct. Debug. Display could be useful, but probably not. Display is for end users, but developers can use debug to print what this thing is. We definitely want to be copy and clonable. Would we want EQ on this? I don't know. Should I put that in here now? I don't know. Maybe we wait until somebody files a bug report and says they need it. But debug copy clone makes sense. And the original definition here, you can see it said repr C, but this doesn't need to be repr C. This is just for Rust code. All right, now let's go ahead and replace our API with this definition that we've created. So instead of TB create accounts result T, we want to have a TB create accounts result. Error create accounts result. And I think I want to call this create accounts result, not TB create accounts result. Because again, I'm trying to figure out whether to be consistent with, the naming in my Rust API or the naming in the underlying Tiger Beetle C API. And just looking at these structs together, I prefer to not have TB create accounts result, but just create accounts result. And now I'm looking at create accounts OK, which is what contains this. And, the naming here I'm very confused about because there's all kinds of OK error result terms being thrown around here in ways that are kind of contradictory. So if we look at our method on the right-hand side, we see create account result turns us future of a result where the OK type is a vec of create account OK. And this result, I don't remember what the error type is here. This might be anyhow for now, an anyhow error, but I don't remember. Be good if I could remember that. Yeah, you see I've imported anyhow result here. So when I use the results type here, this is an anyhow result that could return an anyhow error. This anyhow error is not suitable for production, but it's what we're using for now. But this particular request has two layers of errors, actually. The top layer of error, that anyhow error, is really for like a malformed request or a request that doesn't make it to the server. When we get the result, we also get this vec of what is called a create account OK. But these actually could be these actually could be errors. And so I'm kind of looking at my types here, and I think I've got some naming problems here. This is really not OK. This might be more of a create account result. But then if this is a create account result, then I don't really need a special type here. I can just use the Rust result type. But then if we look at our other API, this is not a this is not a result. This is not like an OK error. This is a found, not found. And so I want to, within these APIs, I want to have the same pattern. So like I have a result type here, and these result types basically look the same. So I definitely do want to create some kind of custom enum right here for the result of create account. But calling it create account OK seems like it's kind of wrong now, since in here, this is create account result. And this create account result is named that way because that's the underlying data type that is used by the TB client library. So I don't really want to rename this type like create accounts error necessarily. So I'm kind of a little confused about exactly what I want to do with this right now. I'm going to keep along this pattern for now, where there's some enum returned for every result, and then there's probably a positive case and probably a negative case. But really, this whole create account OK here probably could be create account result. And this create account result has got a field in it, but this result type that's right now defined as U32 is going to be an enum. So this whole thing could be an enum. And there's like several layers of data types here that all might end up collapsed into just one data type before we're done. But for now, we got to configure the pattern. We got to continue on the path we're on and, get this pattern building, and then we'll, move on to some more ideas. So let's just check this. And this is definitely not going to work because now we are trying to put a underlying CTB create accounts result into this create account OK struct where we expect to create accounts result Rust type. So what I think I want to do is go down to whatever that line of code was, 168. And I'm just going to call into on this. And then up here, I'm going to define the into, an impl of the into trait for create accounts result. So for an impl of the into trait for the C create accounts result type. So I want to say impl into, now I have to remember exactly what the into trait looks like, which is, who knows if I can remember that, into create accounts result, because I want to create one of these, and what I have is the underlying TBC, TB create accounts, create accounts result, create accounts result. And this should be pretty straightforward to implement. Function into, and this self type, we're gonna, don't know if that's a reference or a by value, but probably the compiler will tell us if we get it wrong. So this is gonna take a TB create accounts result, potentially by value, because we put a reference in front of self, and it's gonna give us a create accounts result, and this can't fail. And we're just going to create it and assign the fields to the fields. But now we're skipping out on the index field. So no index field here. Let's see if that builds. And I've done a syntax. This equals is supposed to be a colon. And I got a name incorrectly. TB accounts result is actually result T under there. And I got the name wrong again. Forgot to put that T there. And you can see right here. So before I hypothesize that this self is by reference, it's not, it's by value, and it's telling me exactly what I did wrong. That's all perfectly fine. We intentionally are leaning on the compiler to tell us exactly that. Okay, it's saying it's not implemented for the reference of that. It's not implemented for the trait from. Oh, interesting. So into and from are very closely related. Into and from are very closely related, and probably the into implementation that the compiler is attempting to use here is one that is based on the from trait. So it is probably attempting to use like the by reference from trait implementation. And I implemented the by value from, or implemented the by value into. And this into implementation the compiler is trying to use internally is not my implementation. It's one in the standard library that uses this from. So probably the thing to do, into and from in Rust are very related, and generally you implement one and you get the other for free. So probably I did it backwards, and you're supposed to implement from and then you get into for free. But also it's saying that I could probably do this, and this might work. So let's just go ahead and do that first to see, but we'll probably go and implement from instead. Chad, I see you. I'll respond in just 1 second. So if we dereference this into a by value type, then it might call the correct into method. Yeah, it does. But still, this is probably not the thing we want to do. We probably want to go try to implement from instead. So I'm going to undo what I just did there. We'll see what happens. Yeah, Future Highway says, would implementing the into trait not expose the C type in the public API? And I think it would not, as long as what exposes the C type in the public API right now is the fact that we are saying it's public and the module is public. So these are the underlying C API. So if we pub these mods or we pub this use, then that is directly exposing it to the API. And putting it in like our other types that are pub forces those to be pub. And in fact, this might not compile if I were to make the import private. It might complain that like I'm trying to like expose a private type through a public API. I think the compiler will see that and make that an error. But just implementing this, in general, I would say no. If I just implement a trait on a C type, it's not going to expose that C type to the public API, with possible exception of some weird trait resolution like inference cases that I might not be able to imagine right now. But it's the type itself being public that makes this kind of exposed publicly. Like in the docs, like the docs are going to see, like if it's going to go document every instance of into, they'll see that this thing is private and it will not tell you that this happens to implement into because it's uncallable from anywhere. But this might not literally be uncallable because of trait inference. Like not exposing this in the public API will mean this is not nameable, but in Rust, just because a type isn't nameable doesn't mean it's totally unusable. It might be that because I've implemented into here, somebody that is receiving this through an unnamed type in some way could somehow invoke this implementation. So that's a great question, Future Highway, that I don't entirely know the answer to. This into might be reachable from outside the crate because it's implemented for this private type. But it's basically not reachable unless you run into a interesting type inference situation because this type is not nameable. So I guess the main answer is I don't really know, which is true of many things, and that's okay. But this did build when we made this change. But I want to go ahead and try to implement from instead of into and see if that gets us in a better place or not. So I'm going to say impl from TBC. I'm not going to go read the docs about this relationship between from and into. I'm just going to write the code and see what happens. Create accounts result T for create accounts result. As I was saying before, within the Rust standard library, these two traits are implemented in terms of each other, and most consumers implement one or the other. And I implemented into, but now I'm trying to implement from. Yeah, so Future Highway in chat is saying from gives you into, so I did do it backwards, and we should implement from. From, and I don't know the signature of from. This, I don't think this is a method. I think this is just an associated function. From TBC, TB. I'm just going to guess what the signature is. And here we should just be able to do the same thing. But result is other.result. And then we just delete into because you get into for free. And in fact, that shouldn't compile if you implement both of them. All right, so I implemented from, and it doesn't type check. And again, look, this interesting that it says like the same error as I saw last time. And I implemented from for the reference type here, or for the value type, but it's trying to find the from implementation for the reference of TB create accounts result T, because this is a reference and I haven't dereferenced it. I kind of thought there would be some automatic coercion here to get to my implementation, but there doesn't seem to be. If I were to put an ampersand here, which I don't want to do, I don't want to do that because then I'm going to have to think about naming this lifetime. Like once you put an ampersand in implementation, you have to start naming lifetimes. I don't want to do that, but if I put an ampersand here, then presumably this would resolve correctly. I'm kind of bummed about that. I was hoping I could just implement exactly this without explicitly dereferencing this and forcing it to call by value. But I guess I do. Anyway, the from implementation here is more correct than the into because as Future Highway says, you automatically get into when you implement from. So I'm going to implement from the value type. And generally, I'd rather talk in terms of value types and not implement the reference implementation here. Yeah, sometimes you want to implement both, but right now I don't want to implement both just because I don't want to do it. So here I'm going to say dereference this pointer. Now it'll work by value. Okay, let's checkpoint what we got there. And so now this result is not an integer, it's a U32. So we're going to have to go define that as another enum, and let's just go ahead and bite the bullet and do it. You know, this is kind of not fun, but it's got to be done. This TB create accounts result type has a result integer inside it, and almost certainly this is a C enum. And we can go back to the C client and look for TB create accounts result. Okay, no better documentation here. It's still just a U32. But I'm betting that corresponds to something with an appropriate name. So let's go search for TB create account result. Yep, and see, here's an enum called TB create account result. And we need to duplicate this whole thing in Rust. And it looks like we got to do it by hand. So we're just going to copy paste the C syntax here, splat it up here. And we got to give all this stuff proper Rust naming. So we're going to say this is an enum, and it's going to be create account result. And immediately I'm seeing a problem here because I already have a struct called create account result, which has a single field, which is going to be this enum, which is called create accounts result. So I'm feeling like I need to give in and just say, this is the thing we're returning and forget about this thing. And this is a create account result. So down here I said create account result. Oh, create account OK contains a create account result. Yep, and so this impl that I just created is, this will still work, but we're going to have to do this and redo it. So our create account result is actually just this enum from the underlying C library. And For now, I see the first thing here is an OK enum, an OK variant. And in the API I've defined so far, I already have another struct that defines that. So I'm thinking what I'm going to do actually is I'm going to say, I don't know what I want to do here yet. It's really nice to have one variant that means success. Having the user have to like do a match on this whole big list of variants is kind of a bummer. Like really, it would be nice if this was just a result of create accounts result. So the thing that I'm debating right now is whether to keep this variant here or not. And right now, just based on the API I have, I'm deleting this variant and I'm going to keep all these other variants. And I'm going to keep these numbers to correspond to the underlying numbers. Am I going to keep these numbers? I'm thinking maybe I do, maybe I don't. Like if I keep these and I try to do the conversion based on these integers, then I have a big problem if they're out of sync with these integers. So really, I may or may not want to keep these numbers assignment for these, but I've also got to rename all these, give them Rust names. So this is going to be extremely boring for a while, and I am sorry about that. So all this create account, this prefix got to go away because that's not like a proper Rust naming convention. So we're going to do a replace string, tb create account underscores with nothing. So these are the names of the Rust results variants, but not capitalized like this. I'm sure Emacs has some way to convert these cases to like camel case. Case convert. Oh yeah, there's got to be some way to do this case change in Emacs chat. I just don't know how to do it. Apropos. Case. I'm doing the Emacs health thing like I know what I'm doing, but I just, even after like 20 or something years of using Emacs, I just barely understand how to use it. Let's search for the word camel. Capital. All right, I'm not seeing anything here. Yep, we're going to do it by hand. And for now, I'm deciding whether I want to keep these or not. I think I don't. I think it's too brittle to keep these. And when we do the conversion, that means we're going to write out by hand like this in the Rust version equals the same thing in the C version, because then it's, when you change it in the future, it's just going to be so much more maintainable than if we just try to do a cast from the integers to the other integers. So I'm just going to get rid of these. And in order to keep talking while I'm doing this, I will keep saying the thing I'm typing, imported event expected, imported event not expected, timestamp must be 0, imported event timestamp out of range, imported event timestamp must not advance, reserved field. You know, sometimes we know that there's going to be some kind of macro you can run to do this automatically, but like spending 10 minutes just typing is not so bad. You know, I could go read documentations or just brute force it. Exists with different user data 128. Exists with different user data 64. Exists with different user data. Now, I know before I said it would be brittle to leave the numbers in, but also retyping all these things introduces a high probability that I'm going to write a typo. Yeah, Highway, VS Code is something that I kind of envy other people having access to. and I've not ever really committed to learning VS Code. It's because I'm so used to Emacs key bindings especially, but also like I really love that in Emacs I can just stay in the terminal all the time. And that's especially nice when like shelling into random machines. And so many of these modern graphical UIs, they're very cool, but they're not in a terminal. And I know some of them, I think, have some kind of like remote capability where you can run a server on one machine and the IDE on the other machine. So you could still like SSH into another server and then have your client on your local display. It's very complicated. It's so much easier to just have Emacs everywhere and not think about it. And like even on this machine, even if I wanted to open up Visual Studio Code, just to do this transformation, like I'm running on Windows machine under WSL, so I would have to have that, VS Code server thing set up, and I don't have that set up and ready to go as is. And I know I've been talking while I've been doing all this, and I've definitely made typos. Those will haunt me for a long time, probably. Ledger must not be 0. I'm definitely regretting my decisions here. Imported event timestamp. Oh, there's one. There's a typo. Timestamp must not regress. And that doesn't seem that bad, but also when you think of the conversion functions I'm going to need to do the changes, the conversion between the C type and the Rust type, it's going to be a lot more typing. Let's see where we're at. I kind of lost track with all that typing. All right, cannot find type create accounts result in this scope. Create account result, create accounts result. Yeah, okay. So remember, this type doesn't exist anymore. Now it's create account result. And pub enum cannot find error create accounts result. Same deal, but down here, create accounts result doesn't exist. Okay, so this again seems pretty straightforward, but now we have this unimplemented conversion function here. So I'm going to go ahead and implement it, and it's going to be more typing. And to do this, I am probably going to need the underlying C bindings, C definitions again. So we don't want to match other. Other is a struct, and the result field is, oh, this is so nasty because these numbers, hopefully there's no gaps in them. But if I just match on the number and convert the numbers, if I just match on all the possible ones that I know of here, then I'm going to have to say like match tb create account. Let's see what the first one is. Linked event failed. And that's going to be a create account result linked event failed. And if I enumerate all those, there's still more numbers here that I have to do something about. And it's going to basically indicate like, it's going to basically be a future hole, a future bug, where once the underlying API adds more possible results here, I'm going to miss them here. So this is a pretty darn bad smell to me. I don't like this at all. I really want to automatically be able to convert from these numbers to this enum, which I could do with, if I say this is, for example, REPL U8, then I could cast these numbers to one of these. But even then, you have to deal with a case where you have like a number here that isn't actually represented in this enum. And there's just always the possibility that it's not, you haven't updated this enum. Sorry, Chad, I'm kind of drifting off. So Future Highway is asking like, yeah, we could have an other here. So we could just put a placeholder here. And then down here in our, this is like something we haven't seen before. Or maybe unknown or something like that. And then down here you could say everything else is a create account result unknown. And then maybe you can even add like a log here that says like, hey, I just saw a possible result that I didn't know about. That's a bug. File an issue. That is probably an okay. I don't hate that. I don't hate that. It definitely like gives you something that'll keep working in case you screw up with maintenance in the future. What I would rather see is some kind of test case that honestly just parses out this struct, this enum in C, and exhaustively tests every possible result type that the C API presents. In Rust, you would definitely have like, in a Rust API, if you had this problem, you could have like other crates that would apply macros here that could do things like count the number of enums or count the number of variants, and you'd have a lot more metaprogramming support. But in the C API, I don't know if there's anything we can do to like say like, well, how many variants are there of this enum? Because I assume these are not just copying up. I assume these are not, well, one thing that is pretty common is for the API to say like max or something like that, and just explicitly give you a variant that represents the maximum value of this enum. But that is not present in this API currently. You can see that the maximum value is not even in order. These aren't even listed in order. But it looks like it might be 24, 25. Nope, down here is 26. So this seems likely to expand in the future. So even if it did, putting a max here really wouldn't help you, because that max would have to change in the future as these expand. Yeah, probably what I'd really like to do is put a test case here that just like parses the struct out of the header. But for now, I like your suggestion that we just put an unknown here. And if we ever see it, it's like, that's a mistake. I could even call this like to do or something. But I'll call it unknown. Yeah, I don't think non-exhaustive would help, because I would still like have to do something in this branch right here. I mean, honestly though, your non-exhaustive is useful here. So in Rust, these enums are exhaustive, which means when anybody uses them in a match statement or some other similar control flow constructs, they have to enumerate every single variant. But often in API design, you find that like I didn't know every single possible variant that there would be now and forevermore. And so like a year from now, when we expand the underlying number of errors in the C API, we're going to have to do the same thing in the Rust API. And so that means we'll be breaking the API, because somebody who had already thought they had handled all the cases wasn't actually handling all the cases. So in Rust, you don't really want to be breaking the API like that. And if we do want to break the API like that, we have a responsibility to make a major version bump. And that's a big pain in the butt to do a major version bump just because we added one more error case here. So in Rust, you can actually say, we're not going to REPL U8 this, but we can say non-exhaustive, and that will tell the compiler that like the user actually can't exhaustively match this enum. It'll always act like they didn't account for some cases. And that makes the API stable as we add more and more of these variants over time. And actually, we probably do want to do that. So good suggestion, Future Highway, even though that doesn't help us like future-proof against handling new cases, it does allow us to expand the number of cases in the REST API without breaking the API. So we will do that. We will actually make this a non-exhaustive enum. So way back to the task at hand. For now, we're just going to say if we see an error code we don't recognize, we'll create this unknown error. And then we really can't do much with it, but that's a bug if we ever see that. And then in the future, maybe we can write a more solids test case to make this case impossible. I might say to do, I don't want to care. I want to keep making progress. Don't want to yak shave too much. So the next thing to do is fill this thing out. So what I'm going to do is copy all the cases, all of them. And I need to actually import these into this function because these all live in the TBC module. So here, I'm just going to, inside this conversion function, I'm going to say use TBC everything, just so I don't have to put some module name in front of these. And this OK case here is special because, again, in the API as we've defined it now, we have another struct that represents this OK case. So I'm going to just stub this out and say this is unreachable. And this macro just indicates like I didn't think this branch was reachable because our code is never going to call this conversion function in this case. If it was possible for other code to call this conversion function, we'd probably have to do something more sensible here. And then all of these, it's time to just type more. Linked. Okay, another thing we can do here, like we imported the C code as a star import here, we can also import all of our variants, because normally if we don't import the variants, we have to write create account result : something. But since here I'm about to be writing 26 of these cases, all with that prefix, I'm going to say use create account result star and just bring them all into scope just for this function. And all right, now it is time to write a lot. Linked event failed. Linked event chain open. These all need to be arrows. Imported event expected. Imported event not something. I'm just hitting tab and Emacs to completion once I've written enough. Timestamp must be 0. Imported event time event typoed must not regressed. Out of range, that's ours. Imported event time something must not advance. Must note advance, chat? I knew this was going to happen. Must note advance? Nah, it was not advance. Well, at least this exercise of, rewriting these cases all out gives me another pass to proofread. Sorry, it's late. I say it's late, but also like my memory is just not amazing. Exists with different flags. Exists with different user data. Exists with different user data 64. And these are all fat arrows. Oops, that's not a fat arrow. That's a fat arrow. That's a fat arrow. Yes, arrows. Get those arrows in there. Exists with different user data. So what I'm going for when I'm doing this, just having to type and type and type, and I have to also keep talking when I'm typing. I'm just trying to stay cool and be like, make some kind of like what are the ASMR type of sounds, right? Just stay cool and calm and talk softly and soothingly. So I hope that exists with different code is, a soothing thing to say in this situation. And that exists is a soothing concept. Flags are tab mutually exclusive, soothingly. And these are all fat arrows. Yes, future highway fat arrows over here. Debits pending must be 0. Debits posted must be 0. Credits pending must be 0. Credits posted must be 0. Ledger must not be, I did it again, must note be 0. Proofreading. Ledger must note be 0. Code must not, oh, I did it again. All right, that's something we've learned about me is I want to write not as note all the time. And then finally, imported event timestamp must not regress. Let's see if that checks. Doesn't check. Let's see what's going on up here. Looks like syntax stuff. Line 67. Yep, missing comma, missing comma there. Let's give it another try. Looks like more syntax stuff. Yep, missing big arrow, fat arrow. Yep, fat arrow goes there. And yeah, another missing fat arrow. Cannot find value. ID must note be must note be 0. Line 70. ID must not be 0. This is exciting stuff. And here I said this was a U8, but this discriminant in C is a U32, so it's a U32 there. Okay, tons of, oh, this is gross. This is just a Rust lint that it's not liking these, oh, this is actually, might indicate something much worse. So I'm attempting, I'm attempting to match these values, which are in Rust defined as TB create account. This could be a very TB create account link event fail, TB create account result. Ooh, okay. Yep. So this warning is actually telling us we just made a huge mistake, and the warning looks very innocuous, actually. It says variable TB create account OK should have a snake case name. But I was not trying to create a variable binding here at all. I was trying to match the name of a constant from the bindings module. But this is not actually the name of the constant I was trying to bind. It is instead this big gnarly word here. So when Rust BindGen created its bindings to this enum, TB create account result, it named these as just constants again. Here's our Rust code. These are just constants. That's not a Rust enum. But to kind of distinguish all these variant names, it appended the C enum name with the C variant name to create every one of these constant names. And so I was copying the variable names out of the C bindings, but the Rust bindings named these differently. So this warning, some people would not have understood what was going on here, but I've seen this enough times in Rust that I knew exactly what this was doing. I was accidentally creating a variable named TB create account OK, not matching a constant with that name. So let's fix all these names. And to do that, we can just do a string replace for tb create account with tb create account result tb create account. And that, reads very bad, but those are the name of the variables. And this will definitely not pass certain lints. We'll have to figure that out down the road. But now all these warnings should go away, assuming I've named these constants correctly. There we go. That was a little scary. That's a foot gun in Rust. And it's unreachable. I'm going to put up here. All right, so this is kind of like the kind of stuff we're going to have to be doing for every single request, is redefining these C types to look like Rust types. And now we've done it for one. So let's go ahead and I think we're in this now. Got to continue as we've started, and this create account result we finished. Let's do the same thing for TB account T. And I need to hydrate before we continue. If you've just joined us, we're working on the Rust language client for the Tiger Beetle financial database, which is written in Zig. There is sadly no Zig coding on this stream tonight, which I apologize for, but we are doing some Rust instead. And we're just kind of cleaning up the Rust API tonight. So we have this C type in the Rust API, and we're going to get rid of it by kind of duplicating the definition as a Rust definition. So we're going to go to our Rust C bindings and look for TB client T, not TB client T. We're looking for TB account T. TB account T, right here. And so this is the definition of an account inside of Tiger Beetle. And this is going to mostly be the exact same in Rust. But we can't just reuse this and like type def it to a Rust type, because then the documentation will still expose all this C stuff. So we're going to open code all these conversions from two types that are similar. All right, and these are C types, but we're going to name them as Rust types. And we'll do a string replace for our TB uint 128T to U128. I assume BindGen is not using the official Rust U128 type here because version compatibility. U128 hasn't always existed. But these should all be the same definitions. And then we're going to also need to put that type into this type, account as an account. So you can look up an account and you get either yes, it's an account, or you get nothing, a not found. And I feel like this is actually probably wrong, and there's probably different cases of not found. Like there's probably a bunch of errors here too, and I've just kind of like forgotten to include them. So let's go ahead and I'm going to put a to do because that seems wrong. There must be like possible errors for looking up an account. I mean, maybe it's just not found. I'm going to put a to do there though. And so when we create account OK, and when we do an account lookup OK, we get an account. And down here, there's probably going to be an error because, yes, previously we're putting TB account T into our found, and now we need an account. So we'll go do that conversion on line 366. And we're going to do this conversion exactly like we did the other one with a call to into. And we will just copy the basic signature of from, because again, in Rust, when we implement from, we automatically get into, as we learned on this stream. And we're going from a TBC TB account T to a Rust account. This is a TB account T to a Rust account. And here, we're just going to rename all the fields. It would be possible to use the exact same repr and just do like a mem copy between the two. But in the Rust API, I don't want to even be like, yeah, this is a repr C. There's no reason for the Rust API to be presenting repr C structs. Other debits pending. And again, while I'm just kind of like typing out these long lists of field names, I got to keep talking about something, right? I'm going to say credits pending. Nope. Debits posted. Other dot debits posted. Use self instead of account inside the impl. Yeah, so as Future Highway saying in chat that I can write self here, and I can write self here. Yes, you can do that. It's kind of a matter of taste. I don't know if there's one that's recommended over the other. I kind of pick which one I like depending on the situation. So up here, we could have also wrote self here, because every implementation of a trait defines this kind of pseudo variable or pseudo type called self with a capital S. So anytime we're writing inside of a trait impl or any impl, we can write the word self to refer to this type. I don't think I prefer doing that in this case, though I can't really say why. Like sometimes I like the word self and sometimes I can't really say why I prefer this here. I guess Future Highway in this method, it doesn't really matter to me one way or the other. I would read self just fine. But when I was looking at this one, like, do I want to say use self here? And that just seems kind of convoluted to me to not name like what the variants I'm importing there are. And so like in this case up here, I kind of feel like I don't like naming self. You could also say self here if you wanted. Anyway, it's kind of a matter of taste. I'm going to leave it with the full name. One thing to say about the full name is that it's like more explicit. Like if you're reading this and you see account, you don't have to go cross-reference, well, what is the self type? Credits pending is other.credits pending. Credits posted is other.credits posted. User data 128 is other.user data 128. User data 64 is other.user data 64. User data 32 is other.user data 32. Reserved is other.reserved. Ledger is other.ledger. Code is other.code. Flags is other. So this flags, you could also, we're going to have to do something with this flags, because just giving people a bit field with no way to interpret that bit field is not all that friendly. So in a Rust API, this is going to have some kind of support. We either can define what each field means and let them do like the bit math themselves, or we can define this as a bit field type, which there's crates for doing that. But we're going to have to put a to-do here, because just giving them these bits back is not good enough. Likewise, this timestamp, we'll have to think like, does this actually need to be interpreted by the user or not? Like maybe if this is a logical timestamp, then it's just a number, then who cares? If this is an actual like time that the user cares about, then maybe we need to present like some type here, not just a number. How does the user want to use this? And I think I'll just understand this to do, though. Oh yeah, Future Highway. The issue of lints. There's a number of places in Rust where you can kind of like imagine one way or another to do it. And over time, I have like developed opinions about a lot of things that have differed from what has become the official opinion about how to style your Rust code. So like the more lints get added to Rust's Clippy tool, Clippy collects lints like crazy, just devours lints and has tons and tons of lints about like how to style your code. And it gets more and more all the time. And like sometime every year, there'll be a new lint and it's like says that the thing that I've been doing forever is no good anymore. And, most of the time I'll just be like, okay, we'll do it the official style way now. But sometimes I'm like, I really like my way better. And in fact, somewhere I have like a collection of like a tool for turning off the lints, the Clippy lints that I just really do not agree with. So if we come back to this Future Highway, like toward the end when we need to do our PR, we will have to like run Clippy on this, and we'll probably just do everything Clippy says to do. And it'll probably take like several hours to go through and fix everything Clippy says to fix. And if Clippy says, put self here, then, we'll just do it. Who cares? Flags, okay, gonna have to deal with these some way, sometime. Timestamp is other.time stamp. And let's see if this builds. That's kind of surprising. Okay, so we've converted from account. I think that's like all of the C structs. Now I want to think a little bit about where these definitions live, because these are ugly and I don't want to be staring at them. I don't want to be staring at them when I want to read this code. Like these conversions, I just want to bury them somewhere. And I'm thinking, do I want to also like hide these redefinitions of the C structs? Do I want these to be up at the top, or do I want them to be down low? And I think in general, I think these are not super important. And if I put them after the impl of the client, they will be in more or less a decent spot for reading them. Because again, I generally want to read code top down. So I come into this module and I'm going to see, the subject of this module is the client. And these I think are probably actually not in the right place because these are not very interesting structs. Especially because these are just the results of the requests. If this was a list of requests here, then it would be a pretty interesting piece of API to want to read right away. But these are really just kind of support types for the results of the methods down here. So I don't want them to be up there either, I think. They are part of the API, which means I kind of want them, somewhere up here where people are going to read them because they are public structs. And then this stuff here, this completion method and on-completion function, these are just like implementation details of this module. So I think what I want to do then is make these supplementary structs down here after the implementation of client. And I'll leave the drop method of client up here by the other impls for client. But then these internal details, I'm going to punt these down to the bottom of this file. And this is all subject to change. But I want to kind of be happy with how my code is structured. All right, these are all implementation details of the client. And these are arguments to the methods and return values from the methods. I'm going to put a bunch of white space between them to give them some separation. One thing in Rust that's always frustrating is these impls. It's nice that they are standing on their own, but they're almost always boilerplate, and they're just kind of noise. Like, who cares what all this code says when you're reading this code? It's just in the way. And, it's possible to actually write these in some other module, really get them out of the way. But then there's also kind of the temptation, like, well, this is an impl about account. I should put it near account, but it's all boilerplate, and I don't really care about the details of it. So can't order your code perfectly. Let's make this all still, make sure this all still checks. And let me think real quick about whether there is anything else in this API that is exposed from the C bindings. And this is, okay, so this event right here, the arguments to this event are TB account, which we just recently defined in Rust. So you can say this is an account. So pass us a slice of accounts. But now these events are going to have to be converted to the underlying C accounts. So already we've created the from implementation from, where is it? From TB account to account. Well, to accept this account as an input, we have to have the opposite conversion. So we have to implement from account for TB account T. And that's kind of unfortunate. Like, it's just more boilerplate we have to write. And it's kind of making me think like, well, do we want to just do a bit cast from one to the other and ensure that they have exactly the same representation? But again, from the Rust API perspective, I don't really feel like I should tie the representation of the Rust types to the representation of the C types. So I'm going to go ahead and say, let's go ahead and write out the opposite conversion function from account to TBC, TB account T. This is on account, and this is a TBC, TB account T. And the good thing here is the fields are all identical, so I can just rename this type to TBC, TB account T. And that should compile, but then I have to go use the conversion on these events. And now this is pretty nasty because I have a vec of Rust accounts, but what I need is a vec of TB accounts. And I know I just said we shouldn't just bitcast between these two, but in order to avoid an extra allocation, we kind of have to just bitcast between them. Like, we have to just kind of like unsafely cast this vec from one type to the other to avoid rebuilding this vec. But for now, I'm going to do it type safe way. Again, we're going to come through all this in the future and try to optimize it. But in general, I prefer to make things as type safe as possible and not do casts that rely on the same representation of structs between two different languages. So every time we have to do one of these, I kind of like regret it a little more and doubt my decisions here. I'm going to say let events is a vec of account. Vec of account. And I'm going to get this from an iterator. I'm going to iterate over the input events and create an iterator of the output events and then collect them into a vec. And then we'll do the exact same thing here of converting the new events vec into a unsafe pointer. So I'm going to say packet. I gotta see this code better. Vec from raw parts. So to do that, we have to create a slice. Chat, I am hesitant. This seems like a lot of extra work when we could just bitcast between these two types. Events. Data, packet.data. Events len, data size. It's a callback. I'm just reading what we're doing here. I'm very doubting myself. I'm super doubting myself. So here's we convert from the events input slice to an events vector. And up here, we got to convert it back. So this is going to be a vector of TB account T still. So this doesn't change. It's just that this vector should no longer be oh, this is going to work out perfectly, actually. Never mind all that doubt. This is all going to work. So I'm already reallocating this vector. So while I'm reallocating this vector from the slice, I can also convert types right here. So instead of collecting this vector as TB account T, I'm going to collect it as account. And then here, I'm just going to do a map. And I'm going to map it from, I think I can say from, and just make type inference do magic here. Let's see, check. Expected account, found TB account T. Where is that? 15. Oh, this is in main. Huh. Gotcha. All right, so this actually compiled perfectly. And then in main, now main no longer uses these C types anymore. Now we say TB account. And this is what our REST API looks like to use. So REST API is prettier at the expense of, a lot of boilerplate. But there you go. All that work we just did over the last hour and a half or so was in order to make that line different. Okay, so now the submit create account input no longer uses a C type, output no longer uses C type. No more C types here. All right, that is most of what I wanted to accomplish tonight. Real quick, I just want to look at the error type for submit account lookup. So down here we are account lookup okay. Packet status. Yeah, there's no other possible result. It's either found or not found. There's no more data here to look at. Like the packet itself can have an error, but each individual result, yeah, it either finds the account or it doesn't find the account. Again, I was just, from our discussion earlier today, I was thinking about whether it was possible for there to be an error here, and there aren't. It's just found or not found. Let's go ahead and run the client just to make sure it looks like it's working. Okay. Oh, what is this? This looks wrong, actually. Error timestamp must be 0 for our submit here. So maybe I did this conversion incorrectly. So in our main function, this timestamp, we're setting it to 0 here. Then when we convert it over in this impl of account, not this one here, it's saying my timestamp is not 0. Well, that is fascinating. Other is an account. It's an account. All right, before we try to debug this, I was hoping I wouldn't have to do this. Let's put some valid numbers here and see if we can actually successfully create the account. So those previous accounts were already used in our test database. We're going to create some fresh account IDs and see if we can create new accounts. And nope, you can see our errors for both of those where timestamp must be 0. So I have definitely screwed up something. These look reasonable over here. Let's go to our implementation in lib. This is submit create new account. And here's our vector of events. And to create this vector of events, we're going through all the input events. Vector of events. This isn't a vector of, oh. I did this wrong. Oh, I did this wrong. So I'm creating, input is a slice of accounts, Rust accounts. But this is supposed to be creating the actual vector that we pass to the clients, which is in terms of the C types. So this is actually TBC, TB account T here. That's scary. That's a really big unsafe bug, but caught it. There, now it's a success. So in Rust, we did not define if these were bit compatible, account and TB account T. That would have probably worked, just creating a vector of account and then unsafely telling the client library that it was a vector of TB account. But in Rust, we have not explicitly said or attempted to make this have the same layout as this. So that was wildly unsafe. Okay, well, that's fixed. Let's commit that. Yeah, so Future Highway is asking about forgetting the memory management around these methods. And the question was whether I did a forget on this event vector. I think that was the question. Yeah, and there's a whole bunch of stuff where I'm collecting into an owned thing on the heap, and then I'm forgetting it in some way or another. There's a bunch of different methods that will let you Rust forget ownership of a owned collection type of various types. And in this case, this vector, I'm forgetting it. I'm telling the Rust library to forget this is owned by Rust and don't do anything with this collection anymore. But then I'm passing the pointer off here, somewhere down here, to the C library, TB client. And so at that point, it's an ownership transfer. It's an unsafe ownership transfer, and the TB client is responsible for this vector. And then when we get that vector back in the callback, we immediately cast it back to our Rust vec, and Rust owns it again. So in that way, there is no confusion about the ownership responsibility between both sides of the FFI here. Rust, we're just saying Rust has no clue about this heap allocation anymore. And that's true with a bunch of these. So here, this box into raw is the same thing. That's basically a forget. It's give me the unsafe pointer and forget it in Rust. And there's a few others like that. Here's another box into raw right here where it's like, here's a thing on the heap, and now the other side of the FFI owns this pointer. And then, back up in our callback where the FFI calls the Rust code, the first thing we do is re-own them in Rust. And when you're doing this kind of stuff, when Rust doesn't know about these heap allocations, you got to be careful about panics. Like anywhere the control flow might be interrupted is an opportunity to completely lose those heap allocations forever. So like none of this code is allowed to panic, or else some of the heap allocations would just go missing. But yeah, that's the basic memory management. The ownership strategy in this FFI is put things on the heap in Rust and forget them to the C API. Okay, I think I've done as much as I want to do today. We've cleaned up the Rust API for the Rust client, at least for the request methods that we've written. Next time, we're probably going to take all those patterns we've developed for these 2 requests we've already implemented and just copy them for all the remaining requests. It'll probably take us, 3 more sessions to get them all finished, but we've got the general pattern laid out here and it's all working. And we'll get all these requests implemented, and then we're kind of on our way to like a first MVP of this project. It should all be usable at that point, whether it's all really desirable code or not. It's probably not. There's a lot of heap allocations we have to optimize in the future. We're going to have to document this stuff and write a bunch of tests. So there's still a long way to go, but we're almost at a point where we can like submit a PR and get people looking at this code and maybe even testing it on their own. Okay, so, again, my name is Brian Burson on GitHub, BRSON. I'm streaming, Tiger Beetle hacking specifically on the Rust client at the moment, irregularly, but with some frequency. At the moment, I don't have a schedule, but, I appreciate everybody who's checked out the stream so far, and, I'll be back again within a few days, probably. All right. Check you all later.